Okay, dear students, let us see the solution for this question. Consider the stable closed loop system shown in the figure below. The magnitude and phase values of the frequency response of G of S are given in the table. Now see, here magnitude and phase response given for the this G of S, guys, right? Okay. The value of gain Ki, this value of gain Ki, where K is positive, for 50-degree phase margin. Okay. So for this system, guys, for this system, the phase margin is 50-degree, and for this phase margin, what should be the value of Ki? That they are asking rounded up to 2 decimal place. Okay, so you have to understand the question first. So they are asking the given data is the phase margin for overall system, guys. So here we can write overall open loop transfer function is equal to G of S into Ki by S. Yes or no? This is the overall open loop transfer function, and the phase margin for this is 50-degree. Okay, what is the formula for phase margin? So phase margin is nothing but what? 180-degree plus angle of this open loop transfer function. So angle of this G of S into Ki by S at omega equal to omega GC, guys. Correct? Omega equal to omega GC. So this is equal to here 50-degree, which is equal to 180-degree plus angle of this G of S. Can we write like this? Angle of G of S at omega equal to omega GC plus angle of Ki by S at omega equal to omega GC, guys. Okay, now see, S equal to j omega, guys. If you put S equal to j omega, then this is what, guys? Minus 130-degree, minus 130-degree, which is equal to angle of G of S at omega equal to omega GC. What about angle, guys, here? So Ki, angle of Ki, angle of j omega at omega equal to omega GC. So what is whatever the value of omega GC, this will be the 90-degree, minus 90-degree, right? So here minus 130-degree, which is equal to angle of GH of S at omega equal to omega GC, and this will be the minus 90-degree because Ki positive, angle 0-degree, here 90-degree angle. So if you keep here, guys, then minus 40-degree at omega GC. So here angle of G of S at omega equal to omega GC is minus 40-degree. Now to observe, see angle of G of S at omega GC minus 40. So you'll get the omega GC. You can see here from the table, whenever angle of G of S, this table is given for the G of S. So angle of G of S is minus 40-degree at particular time. The magnitude is frequency is 0.5 and the magnitude is minus 7. Yes or no? So here from the table, we can say omega GC is equal to 0.5 radian per second, and magnitude of this open loop transfer function at omega equal to omega GC at this frequency. This frequency, what is the magnitude, guys? Minus 7 dB. Yes or no? Okay. Now, what is the omega GC, guys? Here, omega GC for this, guys. Omega GC is nothing but what? Magnitude of G of S into Ki divided by S, guys. S at omega equal to omega GC. It is 1, guys. Normal scale 1. So here, magnitude at omega equal to omega GC into Ki, and here omega equal to omega GC. What is the omega GC? Is the 0.5, guys. So this is 0.5, which is equal to 1, guys. Now this is in the dB, guys, and this is the normal scale. So you have to convert this dB into G of S at omega equal to omega GC is equal to minus 7 dB. So to convert in the normal format, 20 log 10 gh of s at omega equal to omega gc is minus 7 dB. So from here, gh of s at omega equal to omega gc is 10 to the power minus 7 by 20, 0.35. So 0.4466, guys. Now you can put the value of this 0 point. So here it is 0.4466 into ki divided by 0.5, which is equal to 1. So from here, ki is equal to 0.5 divided by 0.4466. ki will be 1.12, guys. 1.12. So 1.12 is the right answer for this question, guys. 1.12. Okay. 1.12 is the right answer for this question.